Here we are in Paris in a lab operated by RTE. This lab is dedicated to extensive tests of interoperability between all control equipment in a power system. Today, researchers are working in the framework of the Best Paths project to improve interoperability of different high-voltage transmission equipments. The European electrical grid may evolve from a point-to-point interconnected HVDC link provided by a single converter manufacturer to an HVDC meshed supergrid in which various converter manufacturers will be involved. In such a multi-vendor DC network, interoperability issues between the AC-DC converters are likely to occur. Interoperability means the seamless end-to-end connectivity from different sources of control and command from the power plant generation to the customers. The aim of the researchers here is to evaluate and maximize interoperability of key industrial equipment, the HVDC converter stations, provided by world-class leading manufacturers. The first stage of the project is dedicated to offline simulation of different topologies of high-voltage direct current systems. Here, the direct current grid in the center of this layout is connected to AC networks at each end. The blocks represent converters used to transform alternating current to direct current, and vice versa. This simulation is used to assess the degree of interoperability between converters supplied by different vendors. In this case, the DC grid voltage is supposed to remain stable, but we observe large oscillations which are typical of adverse interactions between the converters. This highlights a major issue for the operation of the system. To refine these results, researchers are working to build a replica of a converter control. What you see behind me is a control replica of high-voltage direct current converter, which operates like the brain of a converter station. It is identical to what is installed in actual high-voltage direct current converters owned by RTE. The main benefit of using such replica is to perfectly mimic a real-world converter at a much lower price than a real converter. Therefore, it delivers realistic simulation results as opposed to digital models which are necessarily an approximation of the reality. We will use replicas in Best Paths to experimentally validate recommendations to maximize interoperability we postulated with offline simulation. Then, we expect to discover new types of interoperability issues, as some types of operations could not be tested with digital models. Finally, we expect the vendors to prove that some interoperability issues can be fixed provided some adaptation of their replica controls. This is the first time ever systematic investigation is carried out on HVDC interoperability, and researchers have observed realistically the problems working with the simulation software provided by 3 different competitors. These efforts are aimed at providing more flexibility of the grid for better penetration of renewable energy at European level.